Okay, suppose that the MWO club has 17 members, and from these members, a president, a vice president, and a secretary will be chosen. Okay, in how many ways can these four... Wait, that's only three. How many ways can these three offices be filled if a club member can only hold at most one of these offices at a time? Okay, so since each one of these positions has a specific role, this is selecting from 17 members, 3 people where order matters. If order matters, we're in the scenario referred to as a permutation. So this is a permutation problem, and using the permutation notation, that would mean that in this case we have 17 objects, and we're going to do a permutation where we select 3 of them. The formula for a permutation, as we've seen before, is n factorial over n minus r factorial. So in this context, n is the first number, n is this number, so we'll be doing 17 factorial over n minus r factorial, 17 minus 3 factorial. And then you're sort of ready to just go do the calculation. But before we move on, before we actually do this, I want to show you how I kind of interpret these. That means I don't have to keep track of an extra formula. I just think of myself as having a bucket here in which there are 17 objects, and then I need to go into that bucket and I need to select 3 of them where the order matters. So as I reach into the bucket, how many choices do I have for the first item, the president I end up picking? The answer is, of course, there's 17 choices, right? Because there's 17 people in the bucket. In the second scenario then, now that I've already chosen a president, and since every member can only hold at most one of the offices, there are only 16 remaining people left for the vice president, and then finally, 15 remain for the secretary. It turns out the simplification up above, if we do 17 factorial over 14 factorial, you'll see that the 14 through 1 all cancel out, and so we are getting effectively the same answer here. Let me just multiply this on a calculator. I would never expect to do this in class manually. And the answer here is going to be 4,080. Okay, so that completes problem number 1. Why don't we do a quick follow-up here? Suppose there's a total of 55 Wolverines competing in a math bowl. And after completing the questions, a gold medal is given to the first place finisher, a silver medal for the second, and a bronze for the third. Assuming no ties, how many ways can these 4 medals be given? Why don't you pause the video here for a second and see if you can calculate this on your own. And assuming that you took a second out there and tried this on your own, let's now do it together. So again, there are 3 options, 3 things that are being given out of this total of 55 Wolverines. So there's my bucket, there's my 55 Wolverines in it, and I'm going to have to go in there and grab 3 people to who I'm going to give a gold and a silver and a bronze medal. How many choices are there for the gold medal? Well, out of 55 people, I'm going to pick 55. Once somebody has received a gold medal, they can't also receive a silver, so there's only 54 people remaining for that slot. And then finally for the bronze, 53. So the answer to this permutation problem is going to be 55 times 54 times 53, becoming a total of 157,410 different permutations. By formula, if you're choosing to do a formula, this would have been a 55p3, and then the formula would have provided 55 factorial over 55 minus 3, which is 52 factorial, and then it's a calculator.